Alright, here we are back again with a little bit of algebra. Chapter 5, Section 5, solving by graphing, or maybe not. Okay, so we have this equation right here, negative x plus 1 equals 2x minus 5. Okay, so a multi-step equation with variables on both sides. Now, in your book, what they suggest to do here is to solve this by graphing, so to split these up. This is kind of in slope-intercept form, right? Negative x plus 1. So I could write y equals negative x plus 1, and then split this one up into y equals 2x minus 5. That's kind of doing the reverse of what we did the other way, where we said I can substitute. If I know that y is this, and I could plug that in for y here, and make this equation. So now they're going backwards, and they're saying solve this by graphing. So graph 2x minus 5, so y-intercept is negative 5, and then up 2 over 1. And then graph this one with a y-intercept of positive 1, and then the slope is negative 1, so down 1 over 1. Okay, so that would look like this, and then the intersection is this point right here. Right here I have negative 5, then up 2 over 1, up 2 over 1. Okay, and then this one starts at y-intercept at 1, and then down 1 over 1, down 1 over 1 until they meet. And that point is 2 and negative 1. That would be the solution to this system of equations. But this equation by itself only has an x, right? So the solution to that is 2. So x equals 2. Now, I would contend that we've already learned how to solve this. You could graph this, but that would be a lot of extra work. So you can just solve this by adding x to each side, plus x here, plus x there. Right, that cancels this out. Now, since we've eliminated x on this side, I'm going to cancel out the 5 here, plus 5, and that cancels out the 5. Now I tally these up. 2x plus x is 3x. 1 plus 5 is 6. Divide by 3, and x equals 2. So that equation is much easier solved algebraically rather than by graphing. But just know that I could split this up. I could look at that and say, well, this is one equation, and or this is one graph, this is another graph, and write it like this, and then graph that. Okay? But you don't need to do that necessarily. We could find the solution from the graph if they just give you a graph. They say, what's the x? Well, then just read it off the graph. All right, now here's this problem, and I told you this comes up again and again. Your family needs to rent a car for a week while on vacation. Company A charges this much per mile plus a flat fee of this much per week. Company B charges $3 per mile plus a flat fee of $150 per week. After how many miles of travel are the costs the same? Notice we are renting this car for a week. So we don't need to worry about per week because it's the same for both. It's 1 week. So it's just the per mile after how many miles. Okay, important information. So we're going to write this down, 3.25 per mile plus 125. Now I could write two equations and then set them equal because they want to know when are they the same. So for the same, I'm going to use equals. And then $3 per mile plus a flat fee of $150. Okay, now solve that. Subtract 3m from each side. That cancels out this. We get 0.25 m. And then since I've canceled out the m on that side, I'm going to subtract 125 from each side. That gets me equals 25. Divide by 20.25. Here's a little trick for dividing by decimal. We get rid of that decimal by moving it over 2 places. So here's the decimal right now. Move that over 2 places. So I have 2,500 if you happen to not have a calculator on you at the time. Divide by 25. 25 divided by 25 is 1. With the 2 zeros gives me 100. So m is 100, which means after 100 miles, 100 miles, the cost is the same. Miles, the cost is equal. All right. Before that, company A would be cheaper. After that, company B would be cheaper. There you have it, ladies and gentlemen. Good times. Check in again next time for another fun video.